Forget sharks. Forget falling off a skyscraper. If you want to know what true, unimaginable terror feels like, you need to look up. We're told the universe is beautiful, a cradle for life. But what if I told you that the simple act of breathing on the wrong planet could incinerate your lungs, turn your blood to gas, or stretch your body into a ribbon of plasma? In the next few minutes of this video, we will leave the safety of Earth's atmosphere and confront the ultimate cosmic horror. We'll systematically explore the death traps of our solar system and even beyond to answer one terrifying question: what is the scariest way to die in space? And trust me, the answer is nothing like what you expect.
Let's start with our neighbors, the inner inferno. When you think of a quick, painful death, you think fire, right? That's Mercury. The problem isn't just the 800-degree Fahrenheit, 430 degrees Celsius daytime heat. You'd be cooked instantly, your internal organs boiling. No, the real problem is the night side.
Mercury has virtually no atmosphere. When the sun disappears, the temperature doesn't just drop, it plummets to negative 290 degrees Fahrenheit. That's negative 180 degrees Celsius. Imagine being flash frozen, every cell turning brittle ice, only for the sun to reappear and vaporize you again. It's a thermal whiplash of unimaginable suffering. But even this pales in comparison to the planet named after the goddess of love. Venus is the solar system's true hidden monster. You might think the surface temperature of 900 degrees Fahrenheit is the killer, hot enough to melt lead. But before you even hit the ground, the atmosphere would have already turned you into a pulp. Venus's atmospheric pressure is 92 times that of Earth. It's the equivalent of being a mile beneath the ocean's surface. You wouldn't just be crushed. Every pocket of air in your body, your sinuses, your lungs, would be compressed into nothingness. You're simultaneously being baked, dissolved by sulfuric acid rain, and pulverized. It is a slow, agonizing, irreversible implosion. It's a terrible way to go, for sure. But here's the unsettling truth. For all their heat and pressure, Venus and Mercury are predictable killers. The outer planets, the giants, operate on a different scale entirely. They don't just kill you, they fundamentally erase you. Before we get to the giants, let's stop at the place we actually want to go: Mars. Dying on Mars is comparatively the most anticlimactic. The main event? Decompression. Mars's atmosphere is less than 1% of Earth's. If you stepped out without a suit, the low pressure would cause the nitrogen and water in your blood to turn instantly into gas, a process called ebullition. You would bloat dramatically, and within about 30 seconds, you'd lose consciousness. The immediate cause of death wouldn't be boiling, but rather asphyxiation and a subsequent circulatory collapse. It's quick, sterile, and cold. A frozen, suffocated death. A miserable end, absolutely, but lacking the theatrical cruelty of Venus. We're moving outward now, past the asteroid belt. Now, you might think dying in the asteroid belt is being smashed by a rogue space rock. Statistically, you're less likely to be hit by an asteroid than you are to win the lottery. The real killer here is angular momentum. You see, if you lose your tether in a crowded field of gravity-neutral debris, a slight bump, a tiny push, sends you into an uncontrolled, endless tumble. You'd be spinning faster and faster, unable to stop. Vertigo, nausea, and vomiting would be instant. Disorientation, panic, and then, slowly, a miserable death by exposure and starvation while tumbling through the void. Imagine your final moments being a dizzying, terrifying carnival ride that never stops. That's a truly lonely way to go. But we haven't even touched the true brutality of the solar system yet. The gas giants don't just offer death, they offer molecular annihilation. Welcome to Jupiter, the King, a planet so immense you could fit every other planet in the solar system inside it, with room to spare. And Jupiter is where physics stops caring about your body's structural integrity. You enter the atmosphere, and the winds are already tearing at you, gusts of 300+ miles per hour. You're a tiny speck in a massive storm. But keep falling, and the real terror begins.
The deeper you go, the more immense the gravitational differential becomes. The side of your body closest to Jupiter is being pulled dramatically harder than the side furthest away. This is tidal force, and it turns a human being into a piece of cosmic taffy. You're stretched thinner and thinner, your bones, muscles, and organs separating under a stress no material on Earth could handle. If by some miracle you haven't been torn apart, you fall into Jupiter's liquid hydrogen layer. The pressure here is measured in millions of atmospheres. It's so high that the hydrogen atoms are squeezed until they shed their electrons, becoming a bizarre conductive substance called liquid metallic hydrogen. At this point, you're not just dead. You've been chemically disassembled. The very molecules of your body reconfigured by forces you can't even comprehend. Saturn offers a slightly different flavor of this hell, but just as definitive. The pressure zones are different, and while the winds are less violent than Jupiter's worst, Saturn has a truly unique killer: the rings. People picture Saturn's rings as a soft halo. They are not. They are a swirling, chaotic traffic jam of billions of chunks of ice and rock, moving at orbital velocities of tens of thousands of miles per hour. Fall into the rings, and you're not crushed. You're sandblasted into oblivion. The high-speed impact of micrometeoroids and ice fragments would reduce you to a fine mist of organic particles almost instantaneously. It's the ultimate erasure. It makes you think, is a quick, violent end better than a long, agonizing one? The next planets will test that very question with two distinctly different kinds of cosmic punishment. We've seen boiling, crushing, stretching, and freezing. Now we look for a world that combines all of it and adds a layer of absolute impossibility. Enter K2141b. This is a lava planet. This planet is so close to its star that its surface is a churning 1,800 Fahrenheit ocean of molten rock. The atmosphere is literally vaporized stone. You wouldn't just be incinerated, you'd be hit by a weather system of supersonic winds carrying pebbles of rock and a rain of liquid silicate. You are simultaneously melting and being pummeled by stone hail, all while swimming in a sea of molten granite. But the lava planet is too fast. It's over too quickly. For the single most brutal, drawn-out, and horrifying end the universe can offer, we must face the ultimate destructor: the black hole. Imagine falling toward a stellar mass black hole. As you approach the event horizon, the point of no return, the tidal forces become absolute. This is where the term spaghettification comes from, and it is horrifyingly accurate. As you fall, the gravitational pull on your head is millions of times stronger than the pull on your feet. Your body stretches like a piece of dough, not snapping quickly, but agonizingly elongating. Your bones pop, your spine unzips, and your tissues are pulled apart cell by cell into an ever thinner stream of atoms, a single-file line of matter rushing into the singularity. And here's the most unsettling psychological torture: time dilation. From the perspective of someone outside the black hole, you appear to slow down, fading to a red smear just above the event horizon, never quite crossing it. For you, however, the fall is finite. You experience your own slow, inevitable atom-by-atom dissection as you rush toward oblivion.
Spaghettification is the universe's most final answer. But is it the worst? Io is the most volcanically active world in the solar system, constantly flexing and deforming under the immense and conflicting tidal forces of Jupiter, Ganymede, and Europa. Its surface is covered in massive plumes of sulfurous gas and lava flows.
Dying on Io is a terrifying combination of being cooked, poisoned, and constantly rained upon by extremely hot, caustic compounds. You are on a planet that is literally tearing itself apart. You'd have the psychological terror of constant, cataclysmic eruptions while being slowly choked and burned by molten sulfur dioxide. It's too hot to survive, but not hot enough to kill you instantly like Mercury. It's a relentless, high-pressure, acidic inferno.
But here is the real, final answer. The one that should genuinely frighten you. The worst way to die in space isn't on a planet at all. It's in the void of deep space, floating between the galaxies. No black hole to end it quickly, no planet to crush you. Just the vacuum, the cold, and the knowledge of your absolute, total isolation.
Out there, you have nothing to orbit, nothing to see, no light to warm you. Just the perfect vacuum, which paradoxically means you don't freeze instantly. You die by slow decompression, embolism, and asphyxiation while being entirely alone. You'd be conscious for about 9 to 12 seconds, enough time for a final thought before the lack of oxygen shuts down your brain.
This journey teaches us one crucial lesson. Life is not a given. It is an anomaly. The universe doesn't care about your pain. It doesn't even recognize your existence. The fact that we are here, sitting comfortably on this tiny, fragile blue marble, is the only miracle that truly matters. Every planet is a death trap. Every environment is hostile. We exist in one tiny, perfect bubble. And that, I think, is the most terrifying and beautiful realization of all. If this exploration into cosmic horror fascinated you, I've got an even deeper dive waiting. We're doing a follow-up on the only 3 celestial bodies that could actually support human life without a full spacesuit. The answer might surprise you. Click the link on your screen to subscribe and join our crew. Until next time, keep looking up, but remember what's out there.